writer. It says it's not easy being human, especially when you're tired and overworked all the time. That's when you become inhuman. I kind of agree and I kind of don't agree, and then every time I read it, sometimes I agree and sometimes I don't agree, which is why I think it's a good quote. I might rewrite it to say, especially when you're tired and overworked all the time, that's when it's hard to be a good human. Sometimes we use, as you've learned in this class, our state of being can influence how we behave in certain situations. So, I added an announcement here. Okay, so they changed our final date. So as of right now, it's going to be in the same classroom, which is not this classroom, S203 at 7:30 a.m. to 9:30 a.m. My expectation is that you're going to use a lot of that time. You're not going to come for like 30 minutes or an hour, but I'm trying to schedule it in a way, content, so that you're also not stressed about the time. So I think 2 hours will be plenty of time. It may be that you have some blank space because you don't remember or you're not sure, and then having a few extra minutes to hopefully access the memory where you remembered it will be helpful. But it shouldn't be the case that you're like constantly writing stuff down for the whole time. The format is different. You know, there's not going to be a take-home part like there was on the partial exams. There's also going to be a lot less information on the paper. So I'm looking for things to come from your head. I'll have cues there on things that hopefully will remind you. But I don't want you thinking this is going to be this like mega true-false exam like we did a lot of the partial exam stuff. So there is going to be kind of thought-provoking stuff from the home part, but it's going to be in the classroom. And I think if you understand the material, have been going to classes, done the homework, you'll do well on the exam. Otherwise, I screwed up. So, the link for the last class is up here. Again, you know, if something happens, for the most part, I'm going to do the class online if you can't get in here. So pay attention for that. The last thing is something new for me, is the cuestionario de opinión estudiantil. I think it's still open. I don't know. Does someone know if you can still fill it out? Okay. If y'all would do me a super big favor and do this, I think you already know by now I have this weird appointment that's called ad honorem, which is Latin for free. But that doesn't mean that it's Latin for easy to get and to keep. Like I actually had to work pretty hard to be able to teach you all here and do the research that I'm doing. So I found out that over time, if I want to keep getting this appointment, which I do, because I've enjoyed doing what I've been doing here at the university and creating and teaching this class, that's one of the things they're going to look at to see if like the kids being also, you know, believe that. And if you don't, then that's fine too, because that'll help me. I'm planning on teaching this class this same semester, but in 2020. That'll help me also from whatever feedback's there. I guess I get to look at, make the adjustments that I need to make sure that you're getting what you're paying for here as a student. So, so whether you liked the class, didn't like the class, learned something, didn't learn, I still want you to fill it out. By now, really, you should be done with the reading and you should be excited that you read the book, and hopefully it's going to change your life in some positive way. If not, basically the exam is going to be on Tuesday, a week from tomorrow. So by that time, even if you have read it, you should at least skim through it And you were given the book, and I had told you can mark it up and stuff. So hopefully, if you read it, you marked up things that you think seem important could be on the exam. For today's class, we're going to pick up where we left off. I've just got a few review slides since it's been a little bit of time. We'll talk about the perspective response process, evaluation and choice. These are slides I showed for a little bit. Then we're going to have a discussion about how we might implement that in AI. After that, I'm going to show you what's the OSI model. Has anybody heard of the OSI model? You may know it from a different name. It's the OSI is Open Systems Interconnection Model. It's a fundamental part actually of computing and computing science. It's the one that says that something's a layer 7 protocol or a layer 3 protocol or layer 1 protocol. Basically, for computing devices, whether it's your cell phone or your computer or your Mac or PC, when you implement software, you're usually implementing functionality that's at one of those layers. So I'm going to review it today. I actually wasn't sure if that was something that you were taught or not, but it's something that will come out throughout your career if you end up having careers that are related to writing software. Generally, systems are divided up and organized in layers. And when you're writing software, you're usually writing at one layer, and it has to interface with the layers that are adjacent to it. So I'm glad. I actually have a lot of slides on the OSI model, which is background for the HSI model, which is a model that we've created and have come to in class. Did everybody do the attendance that's here? Okay, so in the spirit of a little bit of review, because it has been a long time since we've had class, we had gotten to the point where we had what on the surface looked like a fairly complicated model related to occurrences and sensing and our thought processes inside. And here we're kind of looking at it from a simplified perspective. And we're saying that there's a perspective response process that has 3 elements associated with it that are awareness of self, awareness of the influence of others, and evaluation and choice. And that what's feeding this is related to these occurrences which are happening inside of you and outside of you, or inside or outside of the system. And those we get access to through our senses, through memories, and through emotions. Now, when I'm talking about these slides, I want you to always think that these slides are dual slides. They apply to people and they apply to artificial intelligence systems. That's the whole point, what we've been doing in class, is learning from one to apply to the other. So when I say the perspective response process of an artificial intelligence system, that entity, as you know now, ultimately needs to recognize that it exists and that it has parts, and that when those parts move, it influences the environment around it. At the bottom here, it just says occurrences. So evaluation and choice is the last part of the perspective response process that that I just talked about really fast. I just want to make sure you got it, had an opportunity to ask any questions. The idea is that there are these automated condition response systems within your brain and in your body that are constantly making decisions. And for the most part, they're making it without your awareness. It's the thing that's deciding that your head is not like on your desk and it's looking. It's what makes your face move and your head move to look up at the slides. It's what's causing you to hear me It's causing you to have your feet on the floor, not have your feet on the floor. It's what's causing you to shake your head to acknowledge me when I look at you, some of you. So all of these things, what's causing you to be aware that someone just walked in the room. Okay? All these things are automated conditioned responses. If we did not have them, for the most part, we wouldn't be very productive because we haven't spent our very limited amount of deliberate managed response time, the things we can keep track of and actively think about in our consciousness, to handle stimulus that's coming from virtually everywhere. So they're very useful, and in fact, because we develop these things and they become fairly intelligent, semi-autonomous mini modules, as Minsky would say, over our lifetime, we're able to add and become really, do some incredible things that other species of animals and entities aren't able to do. With that comes a lot of, unfortunately, a lot of negatives, because a lot of what's inherent in a mini module is unawareness of automated conditioned responses, which means assumptions. We may assume things that people want, or we may assume that people are certain ways, or we may assume that we may not be successful at something because we haven't been successful before. So, so this is, if there's a battle that we have as human beings, I would say it's not so much the traditional battle that Dr. Feldman alludes to in her book as to like the logical self and the emotional self battling each other. In some respect, it's all yourself, but it's this mini modules of selves that are sort of making most of the decisions throughout your entire life, battling with this self-conscious self, which is trying to work to decide what it wants to do with its life. So when you, at some point in your life, decide you want to eat well, but find you keep not eating well, or you want to exercise, but you find you're not exercising, or you want to take on an online class in the summer to learn more about artificial intelligence, but you find you're not actually doing it, that's where it's helpful to remember back to this class and think, okay, Minsky's mini module that said that they want to do cake. My mini modules are effectively working together for my benefit, and they believe my benefit is not doing these things. So I'm not going to do these things unless I consciously, actively cause myself to do these things because I really actually want to do them. I don't want to just say I want to do them. I actually want to take that class, or I want to do this project, or I want to spend time with whoever this summer. So whatever your goals are for the summer, whether you accomplish them, in large part are making them part of your deliberate, conscious, managed response processes. It's not really mythical creatures in your head, but one way of thinking about Minsky's mini modules in terms of brain processes that are intelligent processes that are working on your behalf, even when you're not conscious about them, is to think about some of these, this concept sometimes you'll hear about an imp or like the little bad guy on your shoulder or something that's trying to keep you from accomplishing your goal. This is sort of related to the concept of the cake from Minsky, which is to realize that this isn't some conspiracy against you or isn't some limitation of you as a human being. It's actually a sign of the things that were supposed to happen happened, and you have begun to automate a lot of the ways that you handle the world. Sometimes those automated ways can be very powerful in terms of keeping you from doing things that you think you want to do. So I'll read from this slide. Self-evaluation involves thinking about your thoughts. It's one of the concepts you'll hear about whether or not a system's alive. Can it think about what it's thinking? So if you have an artificial intelligence system that can think about what it's thinking, then you potentially have something that's approaching an AGI. Recalling that your mind creates your reality. So we've talked already about now artificial intelligence systems having concepts about what should happen. That way they can process information in real time, pay attention to the things that are happening that are different than what they believe should have happened. And then the thought process of altering your perspective over time in order to alter the reality. And this is the shifting of the responsibility of your decision making, wherein it's important, from the automated conditioning responses, the mini modules, to your conscious thought. If you've chosen your goal, this may be a little inspirational because we're close to the end of class, but if you've chosen your goals well, the perspective process is intended to help you make decisions that are working towards your goal. Any questions? Does everybody understand the perspective response process? Any questions about it? Okay, so definition of perspective allows the AI to manage its responses using time so as to exercise autonomy, free will, and influence its realities. So that's the goal. An autonomous AI response process must include deliberate managed responses considerate of what is important to the AI itself. So over time, the AI system on its own is going to determine what's important for it. It may determine that picking up after you in your room is not important to you. So it's a little bit of shift in concept. When we're programming a human perspective AI, we're more oriented around allowing it to develop a concept of the environment that it's in, right? And then influencing the environment it's in so that it'll learn. We're not telling it what the right answers are. We're not necessarily giving it a value system. You could, but then you're not really going to create an independent AI. So the idea is just like a human or a child, you're creating environments where that you hope that it's going to learn how to be a productive, useful entity, right? Because your AI is going to see what other AIs are doing, right? Or it's going to see what humans are doing. And it's going to see how its models adapt and grow over time. This I would expect, actually, if I were to draw this student-adapted model and it was completely empty, I would think that you'd be able to fill it all in just by thinking, not by memorization. But if you're at the point in this class and you create a blank version of this and you find that you don't know what to write down, then I suggest you might want to start memorizing, because it's not what I would recommend. But I think by now you should know what to put in here, just from the learning. You might remember I had borrowed this on the left. We used it for a lot of the first class, the first month. And it was sort of this simplistic, serialistic version of reality that was created by the professors in class. I didn't really think it was all that great a model. We like artificial intelligence, someone from computer science trying to apply computer science to humanity without really spending time with it. not saying it's a bad model, I'm not talking about that. But I can see just from looking at it that it was missing. So that's why we spent, when I knew the model had to be a little bit more complicated. But that's why we spent time to make sure that someone in this class, and more, most of the class got this in their lives. Actually, I don't even remember who the student is. If you're the student, you remember that actually the student. But now this is really the model that better explains what we learned about. Go back, look through your slides, and try to look at this quickly. As you're studying for your exam, you have this model, everything you learn in the class should fit somewhere on the right. Sometimes having these models are helpful for us to remember information that's important. So now, since you understand, because I asked the question, does anybody have any questions about the perspective response question? The process, no one said anything. We're going to have a little class discussion now. And we're going to talk about implementing perspective in artificial. So if you think about the sort of computing systems that you're familiar with today, and you think about some of the aspects that we've learned in class, the question is, if we wanted to give a Sophia some perspective, what are some of the things that we would need to do in order to begin giving Sophia or an entity like Sophia some perspective? Situation we're in, yeah, I would say that's absolutely the likely the number one thing that needs to happen. So I'm going to repeat it here just because I'm doing this recording. Some of you might want to go back and see some of the class while you're studying for the exam. So the comment was space and time. And that really hammers the nail on the head in terms of perspective. So how can Sophia gain some knowledge of space and or time? Yeah.
To the internet, like also location of love. But if you want the internet to keep time between it's not possible.
That's interesting. So two things that I heard. One was having some externally referenceable time, based say on an internet source. And then the other one was having some internal concept of time. So for internal concept of time, we might do something that we tend not to do in computing systems. In computing systems, we tend to want them to give us the answer as fast as possible. We may want to create something that's comparable to a humanistic working period of time. We say, okay, you're not going to make a decision until a certain amount of time has gone by, and you're going to use a certain amount of time to generate additional information for your decision. So that can involve influencing the environment that you're in. We do that a lot. If we're making a decision, we may use that time to go find information, and you could say, well, yeah, but computing systems have access to all the information in the world. But even if you go down that line of thinking, they don't, right? Because they don't have the information. They haven't asked the questions yet, but then they experiment. So you might use time to generate occurrences that give rise to additional information that then influence the decision.
Maybe that affects you, states rate, for example, she's in band, she knows the word, you partner, she knows the moment, so she has that perspective. What I'm trying to about where I am, so it's better, I'm better off answering
Mm-hmm. Right.
So I think that's important about after instead of trying to experience them, you can say later. Then we have of my room.
Right.
So I think we can with intelligent AI, be protected to our directions.
Okay. Yeah.
I would say all the senses would be like something data. In order to make as sense of the senses, and we'll compare the senses that she is receiving last month, find similarities to try to make instead of what's happening around. And not only sensing, but making a reasoning of all these senses in mind.
Right. And so if we think about, right, we want to give enough flexibility to learn. But we want to do it in an environment where there's some constraint. But we recognize that if we, I think we should recognize by now that if we over-constrain it, then in essence, we're not creating an independent AI. What are some of the factors that motivate humans to learn and accomplish things? And that's a two-part question. So what are some of those factors? And you can say the factor and stop there, but if you want the second part, it's in how do you foresee implementing a motivational factor like that within an artificial intelligence system?
We say some kind of benefits. Like, it's either now, you have so the quality can be giving AI some function by limiting when they can do that specific function. And by saying, maybe you have this set of functions that you can have, but maybe in the future you have all.
Yeah, in fact, a lot of the work in earlier work and even current work in AI does relate to that, to the concept of saying, I'm going to have some rewards and some penalties, if you will, sort of built into the algorithm so that it can be motivated to make adjustments based on trying to have this award, sort of a net rewards over punishment, if you will. The issue there is you're constraining that system basically to have your value system. It's what you've programmed it essentially to do to maximize a variable, which is a reward accumulation. So it's good. It works good, but you can probably see how that's not necessarily going to give you a more evolved autonomous AI. And as an example of that is, I don't know about you all, but I know for me and most of the people I know, when they grew up, parents used the reward-based system, right? But if you think about the learning that you went through your life and how you are today as a person, I think you'll find that there's more to it than the reward-based, than that reward-based system. In other words, in some cases, actually, from thinking back through my own kids, I tended to use that reward or punishment-based system when I didn't really have a lot of time. When I had time, I tended to use more of a by example or by experience. In other words, they spent a lot more time watching me eat, watching me drink, watching me interact with people, right? And a lot less time having me tell them, oh, don't eat that, or don't use your cell phone while you're at the table, or something like that. If you do, I'm going to take it away from you. In other words, yes, there were rewards and punishments, but those are really relatively small amounts of time when you think about a reward and a punishment. What happens after that is based on how important that reward or punishment is to you, right? So what are some of the other things when you think back beyond reward and punishment that you see as being really influential in your as you've evolved and grown over time?
Very important. How very important. The concepts that each of us are very important. Classify as a result. So I think the way you learn concepts are using them very important. How you teach how to think we have to do after very important. And then so I would say is looking back more anatomical concept we would need work our way up and then obviously realize that it should be the AI very the concepts
Yep. Another great answer. So just make sure they heard. The idea was um, that the AI needs to um, work at the level of concepts. And the level of concepts being making predictions about its environment and choosing what it wants to do within that environment based on its concepts. So if we take, let's evolve a little bit beyond reward and punishment, and go back to social realities and concepts from Dr. Feldman's book. Right? What she's saying is the reality that we create for ourselves is based on the social environment that we're in. So the way that we behave is based on the social environment that we're in. And social environment is not the environment just that you're in today, but it's the environment that you were in yesterday, a week from yesterday, when you were a baby growing up. And all those interactions that you had that created these mature mini modules that now got bored, so they don't really report to your consciousness much. Pretty much know, not to eat hard and inanimate, non-food items, and figured all this stuff out. To build then a layer on top of that, you can do in an artificial intelligence system. You just have to give it experiences. So it'd be comparable to say that, you're a human being, you come here for the first time, no one's ever taught you anything. And I'm going to teach you things by reward and punishment. Maybe I could teach you some basic things, but I'm not going to teach you anything that's very sophisticated because you don't have concepts. And the idea is really that you don't develop concepts without establishing these mini modules. And you can't develop those without having experiences. And we as humans have those experiences with other humans and other entities. So we have concepts of what it means to be plastic, right? And how important we should value that. We have concepts of what if this was glass, then maybe I want to be a little bit more careful with it because I don't want to break it and have it shattered on me. So we have some concept associated with that. What if we, for a moment, just as a thought exercise, conceded that we weren't really all that important, that we weren't really all that unique, but that what we really are is a creation of all of the people that we've ever interacted with, some more than others because they were more meaningful or their interactions were more engaging. We're a collection of all the experiences that we've had, what we've tasted, what we haven't tasted, and the concepts that we've created from them. Would I be able to tell the difference if, in fact, you were a creation of all these experiences and you were a collection, like one of the projects in class, of the other people that you interacted with? I don't think I would be able to tell the difference. Maybe, maybe not. But from a human perspective and artificial intelligence standpoint, that's really all you need to do. If you can create the constructs within an artificial system that it can, in addition to having some system of rewards and penalties, but not an overarching system, right? Because we know even as humans, even in some cases where there's a death penalty, people still do things that cause that death penalty to be implemented. So we know that's not enough, right? How do we do that? We give them experiences and allow them to have some consequences associated with those experiences. Right.
Where you have zero rules defined that do not necessarily constrict in what we want. But from that point on, it's liberty, right? Based on what
Yeah, so just to reiterate, and then unless someone else has something pressing they want to add, we'll move on. But let me make this comment first, and then I'll take yours. So if we think about programming not at a reward punishment level, but at a concept level, then we can start thinking about making some interesting things happen. So let's say the objective of the AI isn't to receive some predetermined reward or penalty, but its objective is to have concepts of the reality around it and what's going to happen in the reality around it based on what is happening and what it does, and to minimize the error on its predictions over time as it has experience. So if the AI does this, it predicts that it's going to see, right, it's got a camera, it's going to see this happen. And if it does, that's fine. It's done a good job. It's maximized that. Now, if it does this, and it sees people on this side of the room, like start ducking, right? Then it knows that there's something it needs to pay attention to because its concept of what it thought it would happen isn't what happened. If it starts seeing that the people from over here are running towards the AI, right? Then it has to think, okay, was it something that I did? Maybe I did this and my hand flew off, right? And they ducked. And these people are coming because it looks like I'm going to fall off. Right? So what if you programmed the system simply to do that? To say, look, you're going to exist in reality. You're going to be able to move. You're going to have senses that are going to adapt over time so that when you move, you're going to have predictions about what you should see in this sense. And that's what I'm going to program. I'm going to program the ability for you to predict what's going to happen, what's happening and what's about to happen. And the algorithms are going to be designed so that you can, over time, minimize the error of your predictions based on what happens. My belief is that if you do that, you'll have made a fundamental contribution to artificial intelligence. And I actually think it's achievable. I think if you take that idea of concepts and programming and concepts and allow your system to sort of develop, that you're going to move a step beyond a simple punishment and rewards. It's pretty much that's how the way that we work. We work that way as human beings. And if you put then this artificial system in a body like Sophia's, adapted over time so it can, move a lot better, has a lot more sensors about what's going on around it, and you let that system grow, that system will be able to program correctly, start creating concepts by borrowing concepts from the things that are around it, whether it's another Sophia robot, or if it's a person that's talking to you. If it's programmed to minimize concepts, because if it has to predict that you're about to talk to me, right? And if it doesn't, then the algorithm is going to say, hey, you didn't predict that you're going to talk to me. And then over time, it's going to recognize better when someone's going to talk to that person again, right? And if you ask a question to it, and the person, does something weird, like, what are you talking about? Then it's going to know that whatever it did based on the concept that it has is maybe a little bit off, right? I'm not saying that's going to create a 100% human being, but I am saying that it's going to take a big step in terms of taking artificial systems to a level where they can start becoming autonomous or semi-autonomous. If you allow them to even just simply have concepts that they have to adapt over time based on minimizing errors of their predictions with the realities. And then, I'm sorry, I have
the AI by, and we are the unique situation when we are on knowledge. We are required to have knowledge by making questions. So we do because we think of AI in terms of already making sense of what's wrong. So we could think of the AI in terms of a slave. Maybe as a good word, is not. Maybe and start making sense of this noise like taking statistics. So the AI is the same. The AI is receiving all this noise the AI is receiving all the stimulation, but nothing about it. And the unique way that it can make any sense of it is like they do statistics of the surrounding of the sounds, of the pictures, of the feel, of the sensations. And after that, for example, the AI information with person, so we use the language as the basis in order to create this concept.
Yeah, that's exactly right. So, and if you think about a baby, we at least all were one. Whether you can remember or not, part of it is remembering that you're inside and then you're outside, and everything is pretty new, right? I mean, obviously, there's a lot of science that shows that the babies can recognize certain sounds and things when after they're born that they were recognizing before. But for the most part, everything's new. Like you've never actually seen a car driving down the road, or had someone stand far away and then move up to them and do things. So from just the basic concept of programming an entity to have to predict and minimize prediction error, you could see how fairly early that entity would have to make sense of some things that are similar to the kinds of things that babies do, right? That sounds that are coming are actually words, and that they contain some sort of information or some instruction. If you've been in a relationship with someone for a while, it could be your mom, a brother, a friend, how many times is it the case that, or how often does it seem like it is that you say something to them and they say something, but you already knew they were going to say that? And then you say something. So with my wife now, it's oftentimes the case I'm like, I don't even know why we talk. Like, because I'm telling you, I already know what you're going to say. You already know what I'm going to say. Now, it's not 100%. If it was, then we wouldn't probably never talk, right? But if you think about the prediction, the concepts that are there and the prediction errors, what it's saying is that If I had been just simply programmed to minimize prediction error, then that's what should happen, because I have a finite vocabulary, a variable, fairly diverse, but still somewhat limited way of putting that vocabulary together to describe things that I know about. Right? I didn't grow up in a black hole, so I'm not going to say things related to that experience. And so it makes sense that if I'm programmed to minimize prediction error and I spend time with a certain person and we have a lot of the same experiences, that I'm going to get better at predicting what that person's going to say or how that person's going to respond to something that I do say. So as crazy as it sounds, if you're patient and build the right algorithms to establish true concepts that can change and evolve and grow over time, based on minimizing prediction error of what's coming in from the senses, whether it's some statistical-based model or some prediction-based model, right? Remember, errors are good. In your AI, you use them so that as it's training, it gets better and better, right, up to a certain point. The same way with that system. And at some point, it's going to recognize words coming from people's mouths. Right? And at some point, then those are going to become mini modules within the computing system where it doesn't make as many errors when it's interpreting that someone's actually saying something to the system. And when it responds, it's going to tend to respond in more meaningful ways, because if it doesn't, potentially, presumably, it's going to be harder for it to predict what that person's going to do. Once to minimize prediction errors, it's going to have to be better at learning. It's going to have to do things. It's going to have to make mistakes. Was there one more comment, or I want to move forward because I think actually we already covered most of what I wanted to get you to, which was the level of thinking about programming based on concept structure and concept learning, and evolving sort of from this level of I'm going to tell it what it's supposed to want to do, and I'm going to reward it or not reward it if it does or doesn't. Not saying that's not a useful construct to do useful things in computing, it is. But to get to autonomy or semi-autonomy, we've learned this in this class that humans work based on concepts and predictions. And not just about emotions. All right, so the OSI model is Open System for Interconnect model. It's a 7-layer model. We're going to go through that. It's all based on communications. And that is that if you're computing anything, there's no reason to compute it unless you're going to communicate it with something or someone or something, or put it somewhere. So I want to remind you, I showed this slide before in class, that anything and everything that influences the world through an occurrence is also a way of communicating. If I see a building across the street and the building's not falling down, the building has communicated to me that it's structurally sound, or at least sufficiently structurally sound that it's not falling down. If I look up and I see clouds, there's communication to me that there may be rain, especially if the clouds are dark. So even inanimate objects communicate. We talked about that if you make a good meal for your friend or bring them flowers or something, then it smells good, you're communicating something. If you make them a meal that doesn't taste very good, then you're communicating something else. Attention. Either that you're not a good chef or that they don't really matter, right? Or you don't like them, maybe. Sometimes you might make something that doesn't taste good. So this is fundamentally important, because then it's actually not just fundamentally important, it's awesome, because it means that we don't have to worry about all sorts of crazy things in our computing models. We just have to remember, we just have to treat everything as a form of communication. So on the left, we're looking at things that we more traditionally have thought about as communications, which are more structured communications based on language, right, that we attribute to humans: speeches, conversations, letters, emails, text messages, debates, books, internet articles, right? This sort of thinking about language and linguistics. But we don't have to treat that really any different than the stuff on the right, which is facial expressions, gestures, haptics, touch, space, smells, flavor, hygiene, artifacts, clothing or accessories, or even inanimate objects here on the right. They all communicate. And the nice thing is all of these things, everything on the left and everything on the right, which I'm going to lump now together, and I don't really care if it's verbal or nonverbal. It's just a form of communication. I don't really care if it's a human or an artificial intelligence system or an inanimate object that's communicating, and I'm communicating to it. Allows me to create a model for human perspective in AI that's 100% communication based. So the 5 sensible energies, all are forms of influence of occurrences, the attributes of occurrences that influence the realities that only matter to us because they're communicated to us through our senses and through our neurons. Right? Same for the artificial intelligence system. So we can take this model of 2 people communicating, which looks really complicated. You remember in the middle part, that's where the occurrences are, because they're influencing the sensible energies. You don't influence the sensible energy either by influencing or not influencing. You can't communicate. An example of influencing a sensible energy to communicate is I'm going to communicate that I'm late to class by not being at the class when you are. So you have a concept that one of your sensible energies, your vision at least, would see me in the classroom, but I'm not here. So I've communicated to you that I'm not here by not influencing your sensible. Now, if you had learned in computer science about the OSI model, which after now you're going to see it everywhere because it's something that I would have thought you'd already know. You right now being like, oh my gosh, this is so awesome because I don't have to learn some crazy model. I'm just going to use the same model I use in computer science because this is for communications and I'm going to apply it to humans. That's what we're going to do in the remainder of the class today. In the next class, I'm going to use the philosophy here. If I'm going to expose this all to you one time, in the next class, I'm going to go through it in painful detail, and that's where we end. Hopefully by that, at some point, either today or next class, I would expect most of the people in the class to have like an enlightenment moment. Okay. So this is the OSI model. It comes from computer networking and computer implementation. If you write any software, it's going to be in this, somewhere in one of these layers. Any framework that you use for app development is going to have partitioning of these layers. The reason you can write an app so quickly in the phone is because a lot of these other layers, they already exist. You already have a GUI interface layer. You already have layer 1, 2, and 3. A lot of them never have to really deal with directly. Sometimes you win because they have to deal with the physical layer. Like, actually, is it going to go out via Wi-Fi or is it going to go out via cellular? If you're writing an app on the phone, for the most part, you don't have to worry about that. But you may at layer 3, because if you go out via the Wi-Fi or you go out via text message, those are going to do, that's different media, and there might be things about your app that you need to care about so that you know if you're in the communicating through that layer. So at the top layer is the application layer. That's what most people think about. That's where the cool stuff is. That's where the user is. That's the fun stuff, if you will. But all this to me is fun stuff. I spent most of my career working at the at the physical and data and networking link layers. That's what allows one system to communicate to another system. So I'm going to go through each part of the OSI model before I show you the HPAI model. So the OSI model is a conceptual framework describing the functions of a network communication system. It's so that when you're going to write software, you should know, okay, I'm at this layer. So you use layers to provide a visual description of what's going on within the whole system. It narrows the sources of system problems. When you're dealing, if you're working in the IT profession and there's a problem, you want to know what layer it's happening at. If it's happening at layer 1, then you know there's a piece of hardware somewhere that's not working. If it's happening at layer 5 or 6, generally it's going to mean that there's a problem with the software itself. Maybe there's a virus. You tend to get less viruses at layers 1 and 2 because they're less flexible. They're dealing with a physical medium. They don't allow a lot of software programmability. In fact, systems over time implemented at layers 1 and layer 2 usually become more implemented in hardware over time, so they're faster. And as people who are in here, because you have a significant interest at some level in software, I can tell you that when you can implement things in hardware, it's really nice. Things just work faster, less bugs over time, because your system has evolved to a point that you can now do things in hardware. As a software programmer, you want to know what layer you're going to be programming at, because if you're in layer 5, you know that your software is going to be interacting largely with software that's at layer 6 and layer 4. So the top layer, that's the layer that most people see. If you're working on a browser, that's that browser interface that you see, that's happening at that top layer. So apps and software, if you're writing HTML code, you're usually running at this layer 7. And if you're writing a new app, you're writing at layer 7. Layer 6 are basically the services that the Android operating system or the Microsoft OS or the Mac OS is providing you to present things. That's why you don't have to always create a new graphical interface. You can draw on those interfaces that have been developed at a layer 6. They also interface with data below. So if you want to process data, decode data, you're going to send video out, for example. You don't have to worry about, oh, I have video, I got to encode it, I got to decode it, I got to send it to, I got to packetize it, I got to convert it to electrical signals that are going out on a radio frequency to some modulation to my Wi-Fi. You don't have to worry about that. So I'm just going to send it. You don't have to worry about that because you're working at layer 7 and you're working at layer 6. So layer 6 is the presentation layer. It's independent of the data representation at the application layer. And it prepares and translates application data so that if it's going to go out at the network, it can be at the form that it needs to be to start working with the session that you're communicating within the network. Encryption and decryption are examples of things that tend to happen at the presentation layer. Because if you want to protect your information, you want to encode it or encrypt it as soon as your user puts it into the application. That creates less opportunities within the system for it to be accessed by someone. By the time it gets to the physical layer has no idea and cannot have any idea what's actually going over it. It knows it's data, but even if it sees the data, it has no way of understanding what that data is because it's been encrypted and it's been encoded. Layer 5 is the session layer. It's basically what prepares you to, at a very high level, say, I want to exchange information with some other computing system. So I want to know it's available. So I want to start a session. There are some different types of examples of sessions: starting a session of communication, ending a session of communication. Protocols like RTP, you may have heard of this. That's a protocol that's used at a session. Another one is Session Initiation Protocol. It's used for voice over IP, SIP. That establishes a session, tears down a session. And a session is all about communications, taking some information or some instruction or some influence at the application layer, and you got to get that out of the system. And thankfully, you have all these layers of services and functionality that exists, so you can be at one layer and leverage what's at the layer above or the layer below. Now, these are things you might be more familiar with. At layer 4, it's related to, you have a session now. Now it's, I'm going to send information. What rate am I going to send the information at? Where does the information go to? Anybody ever heard of TCP? All of you, I think. Right? So that's a protocol that basically runs at this level. So if you're at Verizon or somewhere working on the internet, you may be working at the transport and networking layer, because your solutions are going to be moving data around at that layer. You're going to be bringing in someone else's application data, and you're going to be moving it from one point in your infrastructure to some other point in your infrastructure. Networking is key for that. So if you're working at a Cisco or something, and you're working on routers, you're going to be working at the networking layer. A lot of what your system does doesn't have much of an application except for being configured. A lot of things that are happening are data that's coming in, and you're just looking at the headers on that data. You're looking at the quality of the connections that the router has to other paths, to the city of Denver, to the city of Philadelphia. And you're deciding in nanoseconds, maybe less sometimes, whether to send that packet out that port or that other port. You don't actually even know what's in it. A lot of the consulting I do is with companies that are working or interested in things at the networking level. They want to move data in and out as fast as they possibly can, and they want to screen things at that layer to see if there's denial of service attacks or other things that are happening that they can drop packets at that layer. Internet protocol is an example of a protocol that works at layer 3. A lot of you may not get into layer 2 and 4 in your jobs, but when you hear of like Internet of Things, there's a bunch of protocols. There's an IEEE standard called IEEE 802.15.4, which is for low power, low data interconnected devices. Based on top of that, there are protocols called Zigbee, Zigbee Pro, ISA wireless. There's another one I can't think of, that are basically protocols that allow a device to communicate with another device locally, create networks of devices with each other. So like smart home technologies, if you have a light bulb that can communicate with a wall mount that you can access through the internet, that's all because of technology that's happening at layer 2 and layer 3 and layer 1. So that device can interface with another device and exchange information. So a lot of programming at layer 2, normally when standards are beginning to evolve. When standards have matured, like they have in a lot of Wi-Fi, for example, you'll see most of what's happening at layer 2 implemented in hardware. Dedicated circuits that are fixed because they tend to be faster and cheaper than software. And then layer 1 is literally layer 1. That's where computer science starts to become an electrical engineer. And you literally take that last semblance of a packet and you turn it into an electrical signal. It's going to go over a fiber optic, it's going to go over a wire, it's going to go over the air. So you're turning that into sensible energies. So before that, all that communication was happening within your entity. And if you want that communication to go to some other entity or influence some other entity, it's all about communications. And that's why the OSI model is just a phenomenal model for us to think about in human perspective. How can we adopt this model that already exists? We don't have to create a new one. Because we've learned in HPAI that everything that we are being humans and how we interact with each other, everything that influences it is just communication. So that's my aha moment. It's cool. I don't have to create something totally crazy. I can actually implement our human perspective artificial intelligence, keeping the same communication layer concepts that computer scientists, network scientists, IT professionals already have as part of their basic vocabulary when they develop software. I just need to add on to it the aspects that we've learned in class that are important for human perspective, because we know that our systems as they stand today, they can communicate well with each other, but they don't have perspective. They don't have things like emotions. So I need to be able to implement perspective and emotion, but I don't have to create a new paradigm in terms of the layers. I can keep my layer paradigms. So here on the slide, I trust some of you read it when I show, even though I don't read the words. That system, that every computing system that you have or you've ever worked with, to get that information in and out of it, it's doing it by influencing the sensible entities. And the way the other system receives that data or that information is by interpreting the sensible entities. So our systems are already creating a currency. They're already doing it. You can review that in the slides later. That's just sort of going back to the OSI model in a more structured way. The layers on the top, 7 through 4, are what they call the host layers. The layers 3 to 1 are what they call the media layers. The media being related to, like, is it going over the fiber or is it going over the air? So even though the networking layer or the data link layer doesn't directly create the currents in the sensible entities outside, it starts to prepare the data to go over that interface. So it needs to actually know, is it going over Wi-Fi or not? Okay, and same, layer 3 needs to know that, layer 2 needs to know. Because if it's at layer 3 and it's a network and it's going over Zigbee, it needs to know Zigbee has terrible latency, hardly transmits any data, so I can't prepare an IP request to get a YouTube video. That's just not gonna happen. Right? So there's got to be things that are done at that layer to prepare data that's cognizant of the network of the actual physical layer that it's going to go out of. And so here's where I'm gonna go over this slide quickly because we're getting close to the end of the slide time. Next class, we're pretty much going to spend all the class on this slide. Not on this slide. I've got lots of variations of this slide. Okay. So we're going to go through all of those little by little, and you're going to see whether it's a building or not, what's on the other side. And what I'm going to do is take this OSI model, which is how entities communicate. So give me like 3 more minutes here, and I'll end at a good note for you. So this is how computers communicate. I'll go through this one more time, and then I'm going to redefine the layers. So layer 7 is not going to be the application layer anymore. It's going to be the conscious thought layer. Because I want to tie, still applications in AI, but I want to tie it to the concept from human perspective artificial intelligence that's most relevant for you to think about. So if you're trying to implement something that's more like a thought process within a computer, then you're going to be working at layer 7. Layer 6 is the presentation layer. It's the simulated reality layer. Right? You're going to be thinking based on what you think the environment looks like. If you're creating something that's more of like the concept of what this room looks like, right? And you're going to then make decisions on that. You're going to be working at layer 6. That's the presentation layer. The presentation layer is going to be interacting with layers 7 and 5. Layer 5 being subconscious thought. Right? Those are the mini modules. The output of all those mini modules, if you're working on mini modules for balance, if you're working on mini modules that relate to how far is this thing I'm throwing likely to go? So now I have a robot that's going to be throwing baseballs, right? And I want to throw it a certain distance. I'm just trying to figure out how to do that. It's going to be using a mini module related to lots of different mini modules. Right? If you're working on that, you're going to be working layer 5. If you're doing the subconscious processing, which is basically working on sort of the raw signal data and trying to do some pre-processing pretty quickly, what color is it, what shape is it, that kind of stuff, then you're going to be working on layer 4. Those are the mini module layers, 4 and 5. If you're working on media layers, this is actually where, things like biosignaling, actually doing things, touching things, feeling things, temperature, the point of where things are in contact. Then you're in the media layers. Those are layers 3, 2, and 1, which are comparable to in our system. Coming into the system, a sensor, the processing of that sensor, and then the signaling of that information for some further processing. Or I want to make something move, right, which is the signaling going down the other way of making that move. So completely analogous to that OSI model, and that's what we're going to spend time with. So that when you go into your careers, when you go into the final, not only are you going to have this model that's very clear with all the senses and sensible energies, but you're going to have now this HSI model, which is the human version of this OSI model based on communication. So you'll be able to make sense of the projects that you're working on. You'll say, okay, I get it. You guys are working at these layers, and you're going to be able to use this to help guide you.